All right, next we're interested in the graph of y is equal to x plus something. So in this case, we've got our default. Y is equal to x plus nothing. Okay, so that's just our normal y is equal to x line. And we're interested in what happens as I change this number. And what we saw was that that was effectively a way of changing the position of the graph. So if I am to increase that to 1, so y is equal to x plus 1, what's happening is we're saying take all the original outputs of y is equal to x and increase them by 1. So now where my output was 0, it's now going to be 1. Where my output was 1, it's now going to be 2. Y is equal to x plus 1. That's what that means. So this graph, in effect, gets moved up 1 unit because all the outputs are being increased by 1. And, likewise, if I'm to increase by 2, then the graph is lifted by 2 units, lifted by 3 units, lifted by 4 units, and so it goes. And with straight lines in particular, this number is useful because it quickly tells us where the graph is cutting the y-axis. So when the graph hasn't moved at all, so y is equal to x, it cuts the y-axis at 0. So the moment that we mess with this, the moment we start moving the graph up or down, then that then tells us where the new y-intercept is going to be. So if I move it up by 1 unit, then the new y-intercept is now going to be 1 because it's moved 1 up from there. And if I change it to 2, so y is equal to x plus 2, the y-intercept is going to be 2, and so it goes. And so likewise, if this were to be a negative number, so say for instance y is equal to x minus 1, so what we're saying is subtract 1 from all the original outputs of y is equal to x. So where my output was 0, it's now going to move down to negative 1. Where my output was 1, it's moving down to 1. Where my output was 2, it's now going to move down to 1, and so on. So the whole graph shifts down 1 unit. And if you're to decrease that number even more, then the graph moves down further. And this is the same for other kinds of functions as well. So let's just say we have our parabola, y is equal to x squared, which is the same as y is equal to x squared plus 0, hasn't moved from its original position. If I add 1, then I'm adding 1 to all the original outputs. So my output is now going to be there at 2. This one moves up to 1. This one moves up to 2. And that guy was formerly at 4, is now going to move up to 5, and so on. And if I say plus 2, then my graph moves further up, plus 3, further up, and so on. And if I am to go into the negatives, then we have something like that. And so the telling sign for whether a parabola has moved up or down is in fact that turning point, because we saw in the previous video that when you just have y is equal to some number times x squared, that doesn't affect that turning point. But the moment you're adding or subtracting some number from x squared, then that moves the whole graph up or the whole graph down. And let's just watch what happens with the hyperbolas and the exponentials. I won't narrate that, but I'll just let you look at the visuals and consolidate the effect of adding or subtracting a number to a function for yourself. And I think the thing, sorry, I know I said I wouldn't talk, but what I want to highlight here is that as this graph moves up or down, so does its horizontal asymptote. So see how the original hyperbola, its asymptote, its horizontal asymptote is the x-axis, and as I add 1 to all of the outputs, then the new asymptote becomes y is equal to 1, the output is never going to be 1. Because all those numbers that were approaching 0, you've added 1 to them. So now they're approaching 1, and if you add 2, then they're going to approach 2. If you add 3, then they're going to approach 3, but never actually be 3. If you add 4, then the new horizontal asymptote becomes y is equal to 4. So that's an important thing if you're trying to tell whether a hyperbola has been shifted up or down, and you look at that horizontal asymptote. And likewise, of course, it can move downward as well if this number is negative. Much like the hyperbola, when you add a number to an exponential function, its asymptote is also going to shift. So that's another telling sign. That's a telling sign for an exponential function as well. If you want to see whether it's moved up or down, look at where its new asymptote is.